Hi, this is Seth, and I'm making a Stat 110 bits video about change of variables in one dimension. So first, let's talk about the theorem. Let x be a continuous random variable with PDF f of sub x. Note that we're talking about x continuous. Then let y equal g of x, where g is differentiable and strictly increasing. Then if we want to get the PDF of y, then all we have to do is use this formula. Note that this little x here is actually equal to g inverse of y, and it's the same little x here. This big X is the random variable, but the other two x's here are this guy right here, where little x is equal to g inverse of y. And also the support of y is given by all g of x with x in the support of x. So in other words, once you've found the formula for the PDF of y, you can get the support of y by just plugging in all values of x into g of x, and that'll give you the support of y. So that's a little bit nebulous, but hopefully we can help demystify this a little bit in the following problems. But first, I want to talk about a pro tip. While the change of variables formula is nice, and it should be another tool in your toolkit, definitely start by working with the CDF, and then see if you can differentiate to get the PDF. Even if the change of variables formula applies, it's often not the most elegant way to solve the problem. And so what I like to do is start with your first principles method, and then go to change of variables if you have to. So the first problem that I want to do is let x be expo 1, and y is equal to log of x. I want to get the PDF of y. So method 1 is direct from the CDF. I could use the change of variables formula here, but I think that the most elegant way to solve this problem is just by directly, applying the things that we've been learning from the first week of class. So if I just write down the CDF of y, I can get the CDF of, x just by writing down things that I know about y. For example, I know that y is equal to log of x, so I just replace y with log of x. Then I know I can do, functions to, that should be a less than or equal to. I can do functions to both sides of these things, so why don't I just take e of both sides? And what that will give me is the probability of x is less than or equal to e to the y. But then I also know the CDF of x, because I know that x is expo 1. And if I recall from my table up here, I have the PDF of x, so when lambda is equal to 1, the CDF is equal to e to the minus x. So I can just use this here, which is equal to 1 minus e to the minus e of y, because I'm just plugging e of y in as little x. Cool. This gives me the CDF of y. And then all I do to get the PDF is take a derivative with respect to y of the CDF. I take a derivative, that 1 goes away. The minus 1 sticks around, but the derivative of e to the anything is just that thing. But by the chain rule, I also need to multiply by minus 1 times e to the y, which gives me, when these minus 1's cancel out, e to the y minus e to the y, just using properties of exponents. And then all I need to do to finish up is think about what the support is. Well, I know that x, since x is expo, has support x in 0 to infinity. If I take the log of both of these bounds, log of 0 blows up to minus infinity, but I know that the probability that big X is equal to 0 is 0. So I'm actually okay writing down, minus infinity here, because I know that, it might actually be 0, but that's an event that has probability 0. So I'm okay with writing down this minus infinity. and you know, the log of infinity is still infinity. And I'm done. However, you could also solve this problem using change of variables. And if you were to do that, I want to lay out 5 steps to that problem. So the first thing that I think that you should do is just explicitly write down some functional form for y equals g of x if it's not given to you. If it is, just remember what it is. Number 2, then I want you to write x in terms of g inverse of y. Number 3, I want you to take a derivative with respect to y of g inverse of y. Number 4, I want you to use change of variables formula. And then 5, remember support. Okay, great. So I'm just going to move, oops, I don't want to crop it. I want to move this down here so I have the formula when I need it. And then I'm going to start again. So remember that x expo 1 and y is equal to log x. Okay, so first, can I use the change of variables formula? Well, in order to figure that out, I need to write down y equals g of x, which is pretty simple. It's actually given to me in the problem, which is log of x. You know, recall the graph of log. It just goes something like this. So I know that, you know, g is differentiable and strictly increasing. So I'm okay to use the change of variables formula. And I can check off step 1. Okay, cool. Now, I want to do step 2, which is write x equals g inverse of y. Well, you know, I have this guy, so if I want to get some expression for x, I just exponentiate both sides, right? So that gives me x is equal to e to the y, which means that's g inverse of y is that guy, right? Okay, cool. Number 3, I take a derivative of that guy with respect to y. Now, why am I doing that? Well, because I need that term right here, right? So I've got x, but I also need the derivative of x. So I go ahead and do that. You know, the derivative of e to the x is just e to the x, so I'm good there. And now I can just write down the answer because I have all the things that I need. So f of y, you know, I'm just using this formula right here. So f of x, recall that the PDF of x, expo, right there, with lambda equals 1, so e to the minus x. But remember that this x isn't really, you know, the same x that we want. We want this x to be equal to g inverse of y. So instead of writing down x, I'm writing down whatever g inverse of y is, which is e to the y, because I want everything to be in terms of y at the end here. Okay, great. And then I also need the absolute value of the derivative of x with respect to y, but I've already written that down, so that's just e to the y. Because I know that any, you know, e to the anything is positive, I can just drop this absolute value sign. And I'm right back where I started. Note that that's the same thing, so that's good. So now I just need to do the last step, which is support. And again, that's pretty much the same thing. X is still expo 1, and that still has support like this. And so I take the log of the left side and the log of the right side, and I get that the support of y is minus infinity to infinity. And this is the first part of the change of variables videos that I'm hoping to do. So I hope that you learned something, and catch me for the next one.